Have you ever considered the possibility that you may have already died countless times? You just never noticed? Because your consciousness only ever exists in the versions of reality where you're still alive. This isn't the plot of a sci-fi novel. It's a controversial yet logically consistent idea in quantum mechanics known as quantum immortality. It stems from a broader physical hypothesis called the many worlds interpretation, one of the deepest attempts to explain quantum uncertainty. According to this interpretation, the evolution of the universe is not linear or one-directional. Instead, at every quantum event, the universe splits into countless versions, each representing a different outcome that is real in its own universe. In 1957, a Princeton graduate student named Hugh Everett first proposed this theory. He argued that our reality is not a single, fixed world, but a massive, branching quantum tree of possibilities. In his view, every time a quantum measurement occurs, say a photon passing through one slit or the other in the double-slit experiment, the universe splits into multiple coexisting branches. Each one represents a different possible reality. We only experience one of them because our consciousness selectively flows along a continuous branch. Once you accept the premise of the many worlds interpretation, you can't ignore its most philosophical implication: quantum immortality. Imagine you're a conscious being who encounters a potentially fatal event, a car crash, a natural disaster, or a medical emergency. According to classical physics, you either survive or die. But in the framework of many worlds, both outcomes occur in separate branches of the universe. The question is, which branch does your subjective consciousness follow? Now let's take this to the extreme with a thought experiment called quantum suicide. Picture yourself sitting in front of a quantum gun, a device linked to a quantum measurement. Each time you press the button, the gun either fires or doesn't, based purely on a quantum outcome. According to many worlds, every press creates two universes, one where you're shot and die, and one where you're unharmed. If quantum immortality is real, your consciousness would only ever experience the universe where you survive. From your first-person perspective, you'd never experience your own death. Press that button 100 times, and theoretically, your consciousness survives 100 times, even if that outcome seems statistically absurd to any outside observer. That's the essence of the quantum suicide experiment. It doesn't prove you can't die. It forces us to question what it means to experience continuity of consciousness. Subjectively, it would feel like you never die. You may have died in countless universes already, but you've never been aware of those deaths because your awareness only exists in the one where you're still alive. It may sound fatalistic, but this idea has a solid foundation in quantum physics. In the traditional Copenhagen interpretation, the quantum world remains uncertain until it's observed, at which point the wave function collapses and reality chooses a path. This leads us to one of the most famous thought experiments in quantum physics: Schrödinger's cat. A cat is placed in a sealed box with a quantum device that may or may not release poison. Until the box is opened, the cat is both alive and dead. Its states superimposed. As absurd as that sounds, it reflects the bizarre nature of quantum uncertainty. The key is, observation appears to determine reality. But who's observing? What counts as an observation? Can the observer themselves be described by quantum mechanics? The many worlds interpretation tries to sidestep this dilemma. It suggests that the wave function never collapses. Both outcomes, cat alive and cat dead, truly happen, but in separate branches of the universe. You're simply in the branch where the cat is alive. In another branch, you mourn its death. Many worlds treats the entire system, observer included, as evolving smoothly under the Schrödinger equation, without any special role for measurement or collapse. Every possible result happens, just spread across different universes. This view has gained strong support from physicists like David Deutsch and Max Tegmark, especially as quantum computing has evolved. Many Worlds offers a way to conceptualize parallel computation, where calculations happen across multiple universes simultaneously, though we only observe one result. If the many worlds interpretation is true, then quantum immortality isn't metaphysics. It's a logical consequence of how consciousness flows through the multiverse. Your awareness would always follow a path that doesn't end, like a water droplet endlessly finding its way through cracks in the rock. And you are that droplet, the stream of consciousness that never stops flowing. That might sound comforting. You never realize you're dead, but it could also be terrifying. You may never escape existence. You just keep going, trapped on the edge of possibility. But does this mean you'll live forever? This is the most misunderstood part of quantum immortality. It doesn't guarantee that you'll live healthily, freely, or happily. It only suggests that as long as your consciousness hasn't ended, some version of you will keep existing, even if that version is sick, paralyzed, or barely aware. You might survive a car crash, but be permanently disabled. You might retain a sliver of awareness after a brain hemorrhage, but lose your senses and speech. You could even exist indefinitely, in a barely conscious shell of a mind. This kind of continuation might not be a blessing, but a kind of existential punishment. In that light, quantum immortality isn't hope. It's a logical fate that you'll never witness your own end, because your perspective always slides into the next unfinished outcome. The scientific community treats quantum immortality with extreme caution. First, it's untestable. You can only feel like you haven't died, but that doesn't prove anything about other branches. It also opens up deep questions about the nature of consciousness itself. Is there a single, continuous vessel for consciousness? In a branching universe, does your awareness split or choose? If it splits, then you are a multitude. If it chooses, who or what is making that choice? Can consciousness be treated as a physical variable? In the evolution of a quantum system, thermodynamics also imposes limits. According to the second law, the universe will eventually reach maximum entropy, a state of no structure, no energy differences, in about a googol years. When entropy peaks, no form of consciousness, however defined, could continue to exist, even if you escape death over and over again. The end of the universe marks a final stop. So quantum immortality isn't true immortality. It's the unstoppable momentum of perception along a survival path, a challenge to our basic ideas of self and death. In a sense, it's a mirror showing our fear of oblivion and obsession with existence. You never defeat death. You simply never get the chance to notice it. From the moment you're born, your consciousness is like a one-way train, branching through the intersections of the universe, always taking the route where you're still alive. And maybe that train never stops. So is this a tragedy, a form of fate, or some divine glitch in existence itself? The answer depends on how you view consciousness. Is it controllable, passive, or just a tremor of information flowing randomly through the cosmos? If we someday uncover the physical structure of consciousness, perhaps only then can we decide if quantum immortality is real, or just an illusion born of multiverse logic. Until that day, you may simply keep moving forward, traveling the line of your subjective universe, from one unresolved survival to the next improbable miracle. You might have already died 1,000 times, but you're still here, still thinking about it, still asking if you're alive, which in itself means you're still on the living side of the multiverse. That's quantum immortality, not a myth, but a ghost of physics. It promises no joy, but maybe it never truly lets you end.